Imagine something so small it could disappear inside a city block, yet powerful enough to create an atmosphere bigger than the entire sun. That sounds impossible, like the opening line of a science fiction novel, but it's not fiction at all. It's real. It's happening right now, and the entire astronomy world is buzzing about it. This isn't a planet or a star, not even a massive black hole tearing light apart. It's a comet unlike any other we've ever seen. Its name is 3I Atlas, and in the span of just a few months, it has gone from a faint speck of light drifting in the darkness to one of the most important interstellar visitors in human history. And the more we learn about it, the stranger it becomes. Most comets are predictable. We know what they're made of, how they behave, and even when they'll show up. They follow the same rules, chunks of frozen ice and dust that flare up when sunlight gets close enough to burn them. But Atlas doesn't play by those rules. For something with a rocky core smaller than Manhattan, it shouldn't even be noticeable on a cosmic scale. Yet this tiny traveller has produced a halo of gas so massive, so luminous, it stretches nearly half the width of the sun. To put that into perspective, imagine a pebble on the sidewalk suddenly releasing a cloud the size of Earth. That's the scale of the mystery scientists are facing right now. And here's where things get even more bizarre. The chemistry of this comet doesn't match anything we're used to. It's not just melting water like most comets, it's spewing carbon dioxide in quantities so extreme that entire textbooks are being rewritten. It's a soda factory in space, fizzing and hissing across billions of kilometers, keeping itself alive where normal comets would be silent and invisible. So what exactly is this strange object? Where did it come from? And why does it look like no other comet ever seen before? Those are the questions astronomers are racing to answer, because this isn't just another rock in the sky. This could be a messenger from the distant past of our galaxy, carrying secrets older than our sun itself. When astronomers first turned their telescopes toward the faint blur now known as 3I Atlas, they weren't expecting a revelation. Comets appear all the time, and most of them fade into obscurity. But what they saw with this one stopped them in their tracks. Its core, the actual solid body hiding beneath all the gas and dust, was minuscule. So small it could probably fit inside the island of Manhattan without spilling over. Usually that would mean a comet too weak to do anything interesting. A nucleus that tiny simply doesn't have the gravitational pull or the material to put on a grand show. But this comet decided to ignore every rule in the book. Wrapped around that pebble-sized body was an atmosphere so absurdly massive that astronomers had to double-check their data. The gas cloud, or coma, stretched across hundreds of thousands of kilometers, nearly half the diameter of the sun itself. Imagine standing next to a matchstick and suddenly seeing it generate a smoke cloud bigger than a planet. That's what this little rock has managed to do, and no one can fully explain how. The strangeness begins with the chemistry. Ordinary comets behave like leaky snowballs. They spend most of their existence in deep space, frozen and lifeless, until they wander close enough to the sun for heat to break apart their icy shells. The water locked inside them begins to evaporate, releasing gas and dust that form the glowing coma we recognize in the night sky. That's standard comet physics, but Atlas refuses to follow the pattern. Its coma isn't powered by water vapor at all, not primarily anyway. Instead, it's venting carbon dioxide in staggering amounts, far more than anyone expected. To grasp how bizarre that is, think of shaking a soda bottle. The CO2 bubbles explode out of the liquid with violent force, fizzing and foaming. Now multiply that by billions of tons, and you've got a sense of what's happening here. It's as if this comet is carrying its own pressurized factory inside, spewing jets of gas so violently that it maintains a shroud far larger than anything its size should allow. This discovery flips comet science upside down. Most icy bodies in the solar system follow predictable ratios of water to carbon dioxide. Atlas doesn't. Its CO2 to water ratio is extreme, 8:1, an outlier so far from the average it feels like a cosmic prank. If you were to survey comets in our own solar neighbourhood, you'd find water always dominating the mix with a little carbon dioxide sprinkled in. Atlas breaks that rule so hard it doesn't even look like a comet from here. It looks like something forged under alien conditions, a survivor of a planetary nursery utterly different from our own. That's why scientists can't shake the feeling that it's not just a stray wanderer, it's a messenger carrying chemical fingerprints of another star system, maybe even from an era before our solar system was born. But before we get lost in chemistry, it's worth pausing to appreciate the scale of the spectacle. A tiny core smaller than Manhattan, a gas envelope stretching nearly as wide as the sun. You don't need a degree in astrophysics to recognize how insane that contrast is. It's like watching an ant carry a skyscraper. And the mystery deepens the more we look. Normally, comets that produce atmospheres this large are giant icebergs, dozens of kilometers across, packed with enough frozen water to fuel a glowing tail for months. Yet here is Atlas, an underdog comet with almost no visible nucleus, managing to punch so far above its weight that telescopes can see its halo across interplanetary distances. Astronomers are still debating whether this means the core is far larger than we think, hidden under a layer of dust that makes it look deceptively small, or whether we're truly dealing with a pebble performing miracles. Either way, the universe has thrown us a puzzle that refuses to fit. Adding to the sense of wonder is the fact that Atlas is not a long-term member of our solar system at all. Its orbit isn't elliptical like most comets, looping back and forth around the Sun. Instead, it follows a hyperbolic path, one that enters the solar system once and never returns. That's a calling card of interstellar visitors. In fact, Atlas is only the third confirmed interstellar object ever spotted after Oumuamua and Borisov. But while Oumuamua baffled everyone by looking like a shard of rock with no coma, and Borisov resembled a fairly ordinary comet, Atlas has decided to combine the mystery of both and raise the stakes. It's not just interstellar, it's impossibly active, chemical fingerprints screaming that it was born somewhere alien. That realization gives every observation a sense of urgency. We have one chance, a brief cosmic window to gather as much data as we can before it drifts into the dark forever. And what a chance it is. Think about the timeline. Atlas may be older than our own Sun, perhaps 7 to 11 billion years old. That means it formed when the galaxy was younger, when stars were exploding into existence at furious rates, and planets were coalescing out of cosmic dust clouds that had never known stability. This little comet may have survived supernova shockwaves, gravitational slingshots past giant worlds, and eons of drifting through the spiral arms of the Milky Way. Now, after billions of years of wandering, it has stumbled into our backyard. The odds of that happening are beyond comprehension, and yet here it is, visible in our telescopes, daring us to unlock its secrets before it slips away. This also explains why the comet's chemistry feels so alien. It might not just be unusual by solar system standards, it could be a snapshot of an entirely different way of building planets and stars. In our corner of space, water is everywhere, the dominant ice of comets. But in another star system, under different temperatures and pressures, maybe carbon dioxide ruled instead. Atlas may have been born in a place where CO2 wasn't a trace element but the backbone of icy worlds. That would mean that somewhere out there, beyond the faintest reach of our instruments, are planets and moons with chemistries we can barely imagine, places where alien oceans fizz with carbon dioxide instead of water. Atlas, in that sense, isn't just a comet. It's a postcard from another kind of reality. Of course, mystery alone doesn't pay the bills for astronomers. They want data, and Atlas is delivering plenty. The sheer size of its coma makes it a natural laboratory. Solar radiation interacts with its gases in ways that can be observed and measured from Earth, revealing details about plasma physics, dust interactions, and magnetic fields. In a way, Atlas is like a cosmic experiment already in progress, one that lets scientists test their theories about how comets behave when pushed to extremes. And every night of observation adds another puzzle piece. Some researchers have even suggested that the violent activity might cause Atlas to fragment, breaking apart in spectacular fashion, just like its namesake did in 2020 when Comet Atlas in our solar system disintegrated unexpectedly. If that happens, the show could be dazzling. Massive jets of gas, sprays of debris, and perhaps even a new understanding of what makes interstellar objects tick. But even if it doesn't explode, the fact remains. This is the strangest atmosphere we've ever seen surrounding one of the smallest comet cores ever detected. The impossible combination of size and fragility has captured imaginations not just in science circles but in the public. Amateur astronomers point their telescopes skyward, hoping to catch a glimpse of history in motion. Space agencies schedule precious observation time on the Hubble Space Telescope and the James Webb Space Telescope, knowing that whatever Atlas reveals might not only challenge our assumptions but reshape them. This comet is forcing humanity to look at the sky differently, to realize that even the smallest wanderers can hold the most profound truths. And that's the real heart of Section 1. The impossible atmosphere of 3I Atlas isn't just a scientific anomaly. It's a reminder that the universe has no obligation to play by our rules. We like to believe we've mapped out how things should behave. Comets should be icy, their comas should be proportional, their lifespans predictable. Atlas arrives and shatters those assumptions with the quiet defiance of a pebble, carrying the weight of a star. Its presence challenges us to wonder how many other cosmic visitors might be drifting invisibly through the void, carrying secrets from alien nurseries, waiting for a lucky moment when their path aligns with ours. We may never see another object like this in our lifetime, but while it's here, burning its strange chemistry across the solar system, it demands our attention. Because sometimes the most important stories in the universe are written not by giants, but by the tiniest travellers who dare to shine. The strangeness of 3I Atlas doesn't end with the size of its atmosphere. That's only the beginning. The real mystery starts when you look inside that enormous halo and ask a simple question. What exactly is it made of? Because when scientists pointed their instruments toward the glowing cloud, they didn't see the familiar signatures of water vapour that dominate almost every other comet we've ever studied. Instead, they saw something that made them pause, double-check, and then question almost everything they thought they knew about comets. Atlas wasn't powered by water at all. It was powered by carbon dioxide, massive, continuous outbursts of it, spewing from its tiny rocky core in amounts that make no sense for an object of its size. That single discovery has turned Atlas into one of the most bizarre interstellar visitors we've ever encountered. To understand why this is so unsettling, you have to picture how comets normally work. They're called dirty snowballs for a reason. Their cores are mixtures of dust, rock and ice, frozen together into a lumpy, inert mass that drifts through the solar system for eons. They stay quiet until they get close enough to the sun. Then, as the solar heat begins to thaw them, their icy interiors release water vapour. That vapour, along with dust grains, forms the coma, the ghostly shroud that makes comets glow so beautifully in our skies. In almost every comet we've ever studied, water is the star of the show. Sure, we'll see a little carbon dioxide here and there, maybe some carbon monoxide or other trace gases, but never in amounts large enough to redefine what a comet is. Atlas doesn't just rewrite the balance, it obliterates it. In its coma, carbon dioxide dominates water by a factor of 8 to 1. That's not just unusual, that's unprecedented. If you were to line up all the comets ever catalogued by human eyes, from the Great Comet of 1811 to Halley's Comet to modern-day ones like Hale-Bopp, you'd find the same general pattern repeating over and over again. Water makes up the bulk. While everything else plays a supporting role, Atlas stands alone as an outlier. It's a comet that seems to run on a completely different recipe, as though it came from a kitchen in another universe. And in a way, maybe it did. Because Atlas isn't from here. It's not a product of our solar system's chemistry. It was born far away, under conditions we can only guess at, and its bizarre composition may be the only clue we ever get about the world it came from. Think about what that means. In our solar system, planets, moons, and comets all formed out of the same protoplanetary disk about 4.5 billion years ago. The proportions of elements and compounds in that disk determined what everything looks like today. Water, carbon, oxygen, and other building blocks mixed together in certain ratios, creating the family of worlds we now call home. If Atlas carries a ratio that looks nothing like what we're used to, that suggests its birthplace had an entirely different set of ingredients. Maybe it formed around a star cooler than the Sun, where carbon dioxide condensed out earlier than water, becoming the dominant ice. Or maybe it was born in a chaotic region where violent stellar winds blasted away lighter molecules, leaving CO2 to accumulate in massive quantities. The possibilities are endless, and each one tells us something profound. Not all planetary systems follow the same blueprint. Ours may be common, or it may be rare. Atlas might be showing us the diversity of worlds scattered across the galaxy, proof that creation doesn't happen the same way everywhere. That's what makes its chemistry so exciting to scientists. This isn't just a weird comet, it's a fossil a time capsule carrying within it the raw materials of another solar system's youth. By analysing its coma, astronomers can infer what kinds of ices and gases were present when Atlas first formed billions of years ago. It's like opening a sealed container from the deep past, only this container isn't from our history at all. It's from somewhere else, a place we'll never visit but can now glimpse through this tiny visitor, and the deeper scientists look, the stranger the story gets. The sheer violence of Atlas's outgassing suggests it's not just a frozen rock quietly warming up. It's under pressure, a volatile mixture ready to burst whenever sunlight hits it. That raises questions about its internal structure. Is it riddled with gas pockets that collapse and vent like geysers? Is its crust so thin that sunlight easily penetrates to its core, releasing buried gases in explosive bursts? Or is the comet breaking every rule because it was simply built differently from the start? The soda factory in space metaphor isn't just poetic, it's remarkably accurate. Imagine a sphere packed with compressed carbon dioxide ice, sealed under the cold vacuum of interstellar space for billions of years. As soon as it gets within reach of sunlight, that CO2 doesn't just melt quietly, it sublimates, turning straight from solid into gas, blasting out with explosive force. Every jet pushes dust, rock, and frozen particles outward, swelling the coma into something that dwarfs planets. Atlas isn't leaking gas like other comets, it's erupting constantly, like a champagne bottle that refuses to stop fizzing. And because it's running on CO2 instead of water, it can start this show much farther from the Sun than most comets can. Where ordinary comets remain invisible until they're inside Jupiter's orbit, Atlas can flare up millions of kilometers farther away. That's why scientists spotted its activity so early, and why they're scrambling to capture every detail before it vanishes again into the dark. What's especially intriguing is that this isn't just about chemistry, it's about survival. Atlas has been drifting through the galaxy for billions of years, exposed to radiation, starlight, and cosmic collisions. Any fragile ices on its surface should have long since boiled away. Yet somehow it preserved a reservoir of volatile carbon dioxide strong enough to create one of the biggest atmospheres we've ever seen around a comet. How? One theory is that Atlas was ejected from its home system relatively early in its life, before it had time to lose its ices. Another is that its surface layers hardened into a protective crust, shielding the interior for eons until sunlight from our sun cracked it open. Whatever the case, it means this comet has survived a journey that most objects would never endure, and now it's unveiling its secrets in a dramatic, almost theatrical way. Of course, with every answer come new questions. Why carbon dioxide? Why so much of it? Could this be evidence that some planetary systems produce comets with entirely different volatile compositions than ours? If so, what does that say about the potential for life elsewhere? After all, carbon dioxide isn't just a random molecule, it's central to the chemistry of atmospheres and ecosystems. If Atlas formed in a CO2-rich environment, perhaps that environment also had planets where carbon-based chemistry unfolded in ways we can't yet imagine. Maybe there are worlds out there with skies heavy in carbon dioxide, oceans bubbling with dissolved gas, and climates shaped by conditions utterly foreign to Earth. By studying one strange comet, we may be glimpsing the diversity of habitable conditions scattered across the stars. And here's where the human imagination takes over. It's easy to dismiss Atlas as just another rock, but to those watching through telescopes it feels like something more. Every burst of CO2 is like a whisper from another world saying, "Here's how we did it. Here's how planets were built where I came from." We may never know the exact details of its birthplace, but by measuring its chemistry, we at least get to hold a fragment of its story in our hands. For astronomers, that's enough to spark entire fields of research. For the rest of us, it's enough to ignite wonder. We're staring at a comet that isn't just foreign to our solar system, it's alien in every possible sense, carrying the scars of a galactic journey no human will ever take. The most captivating part is that this is only the beginning. Atlas is still on its inbound path, still heating up, still preparing to show us what happens when sunlight strikes a body this strange. Every day, as the gases pour out, astronomers are recording spectra, measuring the exact fingerprints of molecules inside that glowing coma. Each line on their graphs is a clue. Each burst of CO2 is a window into a chemical history billions of years old. And the more they look, the clearer it becomes. Atlas isn't just a comet behaving badly. It's a messenger from another time and another place, carrying within it the evidence that our galaxy is full of surprises, full of alien recipes for building worlds, full of diversity we're only beginning to understand. When scientists realized Atlas wasn't bound to the Sun, that it wasn't just another comet looping endlessly around our star like a predictable clockwork toy, everything about it changed. Most comets are prisoners of the solar system. They come from the Kuiper belt or the distant Oort cloud, regions of frozen bodies orbiting far from the Sun, and they return again and again on centuries-long schedules. You can plot their orbits like train timetables. Halley's Comet, for example, comes back every 76 years like an old friend who never fails to keep an appointment. But Atlas is different. Its orbit doesn't close into a loop. It's hyperbolic, stretched wide open, like a line slicing straight through our solar system before disappearing back into the void. That single fact means one thing. Atlas is an interstellar traveller. It came from beyond our star, from a place so distant we can only guess, and once it leaves, it will never return. This is a one-time encounter, a brief brush with a cosmic wanderer that has drifted alone in the galaxy for billions of years. Tracing its path backward is like following footprints across a desert where the wind erases tracks almost as quickly as they appear. Astronomers calculated its trajectory and discovered something astonishing. Atlas seems to have entered our system from a direction near the constellation Sagittarius, pointing back toward the centre of the Milky Way. That's not just poetic. Sagittarius is the region where the dense heart of our galaxy lies, crowded with stars, nebulae, and ancient remnants of stellar creation. If Atlas really came from that direction, then it may have been travelling for untold ages, possibly ejected from some star system in the crowded galactic core long before our own sun was even born. That thought alone is staggering. This small icy rock may have been wandering the Milky Way for 7 to 11 billion years. That makes it older than Earth, older than the Sun, older than the solar system itself. Imagine holding a pebble in your hand and realizing it began its journey before our planet even existed. That's what we're seeing when we look at Atlas. Think of what it means for an object to survive that long in interstellar space. The galaxy is not empty. It's a harsh and violent place. Stars are born in explosive bursts, throwing out shockwaves of radiation and stellar winds. Massive stars live fast and die in spectacular supernovae, flooding space with lethal energy. Entire systems are destabilized by passing stars, by gravitational tides, by collisions and close encounters. For a fragile comet to endure all of that for billions of years without being completely destroyed seems impossible, and yet Atlas has done it. Its very presence is proof of resilience, of survival on a timescale we can barely imagine. While civilizations have risen and fallen on Earth, while species have evolved and gone extinct, while galaxies have collided and reshaped themselves, Atlas has kept moving, silently, endlessly, through the dark, carrying the chemistry of its birth system like a sealed message in a bottle. That's why scientists call comets like this time capsules. They preserve the conditions of their birth. In our solar system, comets from the Oort cloud tell us about the early days of the Sun, the icy leftovers from planetary formation. But Atlas is something even rarer. It doesn't just tell us about our own past, it tells us about the past of another system, perhaps one very different from ours, and perhaps from an epoch so ancient it stretches back to the dawn of the galaxy. In its nucleus, in its frozen gases, may lie chemical fingerprints from before the Milky Way looked the way it does today. Think about that. This tiny traveller may have condensed out of a protoplanetary disk, circling a star that no longer exists, a star that may have lived its life, exploded, and faded into nothing while Atlas continued to drift. Its parent system may have been ripped apart by gravitational chaos, ejecting Atlas into the void as debris, or perhaps its star was swallowed into a larger structure, leaving only this lone wanderer as a survivor. No matter how it happened, the fact that Atlas is here means we now have the chance to study not just another comet, but a relic of galactic archaeology. Astronomers get poetic about objects like this because the scale is so overwhelming. Picture Atlas gliding silently between the stars for billions of years. No sunlight, no heat, no planets or moons to interact with, just the cold emptiness of interstellar space. In that vast silence, it would have been invisible, indistinguishable from the darkness. Nothing to mark its existence until by sheer chance its trajectory carried it into the domain of the Sun. For eons, it drifted unobserved, a ghost in the galactic sea. And now, at this singular moment, humanity has telescopes powerful enough to see it, to measure it, to capture data before it slips away forever. The odds of that are mind-bending. Out of all the billions of years Atlas could have arrived, it happens to show up during the brief sliver of time when human beings have developed the ability to detect it. It's as though the universe has offered us a rare glimpse into its archives, one we will not get again. And unlike the first interstellar visitor we spotted, Oumuamua, Atlas leaves no ambiguity about what it is. Oumuamua was a mystery shard, elongated like a cosmic sliver, tumbling silently with no visible coma, baffling astronomers who couldn't decide if it was an asteroid, a comet, or something else entirely. Borisov, the second, was more familiar. A comet with a coma, but still unusual in its chemistry. Atlas combines their legacies. It is unambiguously a comet, with a coma so large it borders on the absurd, but its chemical recipe is alien, its orbit hyperbolic, its age incomprehensible. It's as though the galaxy wanted to present us with the most dramatic example yet. A comet so strange and spectacular that no one could mistake its significance. The realization that Atlas will never return adds an emotional edge to its study. When you look at Halley's Comet, you know future generations will see it again. It's part of our story, a recurring character in the cosmic play. Atlas, on the other hand, is a once-and-forever visitor. When it leaves in 2026, it will be gone for good, sailing into the blackness with no turning back. That's why astronomers around the world are racing to observe it, to record every detail. They know this is their only chance, their only brush with a traveller from a system we'll never reach. There is no second act, there is no encore. There is only now. For the public, it's hard to wrap our minds around such a fleeting encounter. We're used to thinking of the sky as permanent, unchanging, the same constellations night after night. But Atlas reminds us that the sky is dynamic, that the universe is filled with wanderers, that sometimes by luck one crosses our path. It's humbling to realise how temporary this visit is. In just a few years, it will vanish, and the only evidence it was ever here will be the data we collected and the memories of those who looked up to see it. And yet, in that brief encounter, Atlas challenges us to expand our perspective. It forces us to recognise that our solar system is not isolated, not unique, but part of a vast galactic web of worlds and fragments constantly in motion. So as scientists track Atlas's orbit and analyse its strange chemistry, they're not just studying a comet. They're peering into a story billions of years in the making. A story that began in a star system long gone, carried across the galaxy by a fragment of ice and rock, now unfolding in our skies. Atlas is more than a comet. It's a reminder of time on a scale so vast it makes human history feel like a heartbeat. It's a symbol of survival, of endurance through chaos, of the quiet persistence of matter across unimaginable distances. And as we watch it glow against the black canvas of space, we're not just seeing a comet, we're seeing the memory of another world, preserved in ice, drifting into our lives for a brief, unrepeatable moment. If there's one idea that captures the imagination more than anything else about 3i Atlas, it's the notion that this tiny, fragile body is a time capsule, carrying secrets from another world. Not another world like Mars or Jupiter, worlds we can at least study from afar, but from an entirely different star system, maybe even from a star that doesn't exist anymore. Think about that for a moment. What you're looking at when you peer into the comet's vast halo isn't just gas and dust. You're looking at chemistry frozen billions of years ago, chemistry that may have formed under alien skies in conditions so unlike our solar system that it almost feels like science fiction. Yet it isn't fiction at all. Atlas is real, and it's here, and it's spilling its story across the void whether we're ready to hear it or not. Every comet in our solar system tells us something about our own past. The icy bodies in the Kuiper Belt and Oort cloud are leftovers from the earliest days of planetary formation, frozen relics that never got incorporated into planets or moons. By studying them, scientists can reconstruct what the solar system was like before Earth even formed. But Atlas raises the stakes. Its orbit, its chemistry, and its sheer strangeness prove that it doesn't come from here. It's not a piece of our history, it's a piece of someone else's, a fossil from a system we'll never visit. That makes it priceless beyond words, because when you study Atlas, you're not just looking at another comet. You're peering into a sealed container from the galaxy's deep past, preserved against all odds, now opened for a brief moment before vanishing forever. What makes this idea so electrifying is how ancient Atlas might truly be. Our Sun is about 4.6 billion years old, but Atlas could be nearly twice that age. Some estimates suggest it formed between 7 and 11 billion years ago, at a time when the Milky Way was still young, when stars were forming in violent bursts and heavy elements were just beginning to spread across space. If that's true, Atlas predates Earth, predates the Sun, predates the very existence of most of the planets we know. In its frozen nucleus may lie a record of the conditions of the galaxy at that time, a direct sample of what star systems looked like long before ours even existed. Imagine holding a piece of amber with a fossilized insect inside. Now expand that idea to a galactic scale. Atlas is the amber, and inside it are chemical traces of an environment that no longer exists anywhere in the Milky Way. How does a fragment like that survive? The galaxy is not gentle. Over billions of years, comets like Atlas could be destroyed by radiation, collisions, or the gravitational chaos of passing stars. Yet somehow this one endured, shielded by its small size and its icy shell. For billions of years it drifted unseen, a solitary wanderer in the cold, until chance brought it near our Sun. Its survival alone is extraordinary, but the fact that it still contains volatile gases, carbon dioxide in ridiculous quantities, means that it hasn't been stripped bare by cosmic exposure. Somewhere deep inside, its interior remained sealed tight, a vault preserving the conditions of its birth system, and now, under the light of our Sun, that vault has cracked open. Every jet of gas it releases is like a message from the past, carrying with it the fingerprints of alien chemistry. This is why astronomers are so desperate to study it. Every telescope trained on Atlas is essentially a time machine. By analysing the gases in its coma, scientists can figure out what kind of environment the comet formed in. Did its star system have different ratios of elements than ours? Was it cooler, warmer, richer in carbon or oxygen? Did planets there form with compositions we can't even imagine? Each chemical line in the spectrum is a clue, a fragment of a story written billions of years ago and only now revealed. And unlike samples from our own comets, which all share the same basic history, Atlas's composition is something brand new. It's the first time in history that humanity has been able to analyse the raw chemistry of another star system without leaving home. But there's more to this than just scientific curiosity. There's also the human drive to connect, to imagine, to wonder what else might be out there. If Atlas formed in another system, then it's a reminder that planets and comets are not unique to us. Every star has its debris, its leftovers, its fragments, and if this one survived to wander across the galaxy, then countless others must exist too, drifting silently in the dark between stars. Some may pass through our system without us ever noticing. Some may carry even stranger chemistries, hinting at worlds richer, harsher, or more bizarre than we can conceive. Atlas is the one we got lucky enough to see, and its very presence proves we're part of a larger galactic family of worlds, each with its own story. Consider, too, the possibility that Atlas isn't just a chemical time capsule, but a physical survivor of violent events. If it really came from near the galactic centre, then it may have been ejected by a supernova, hurled into interstellar space when its parent star died. Or perhaps it was flung out by a collision with a giant planet, torn loose from its home system in a gravitational slingshot. In either case, it has carried the scars of that trauma across billions of years. Its pitted surface, its volatile rich interior, its wild outburst of gas, all of these may be echoes of a violent birth long ago. Studying it gives us a chance to witness not just the chemistry of another world, but the history of its journey, a story of survival against odds that seem impossible. And there's something poetic about the way Atlas reveals itself. For billions of years it remained invisible, drifting in the dark. Now, as it passes close to our Sun, it lights up spectacularly, announcing its presence in a blaze of activity. It's almost as if the comet has been waiting for this moment, holding on to its secrets until humanity was ready to look up and notice. Its atmosphere, half the size of the sun, is like a beacon saying, "Here I am, pay attention, this is your chance." And once it's gone, it will vanish into the dark again, never to be seen by human eyes. That fleeting nature only adds to its mystique. A time capsule doesn't stay open forever. Once it closes, the opportunity is lost. We have to seize it now or lose it forever. For scientists, the urgency is clear. Every observation counts. Every measurement could reveal something astonishing. Isotopic ratios might tell us about the temperature and pressure of its birthplace. Dust particles could reveal minerals unseen in our system. Even the way its gases interact with the solar wind can teach us about how interstellar objects behave under new conditions. Atlas is more than just a comet. It's a laboratory, a history book, and a messenger all in one. And while the data may take years to analyse fully, the fact that we have this opportunity at all is something extraordinary. Out of the infinite vastness of the galaxy, a single traveller has passed close enough to whisper its secrets, and we are here to listen. And for the rest of us, those who aren't scientists but still gaze at the night sky with wonder, Atlas is something even more profound. It's a reminder that we live in a galaxy filled with stories we've barely begun to hear. Every star you see at night may have comets like this. Fragments of ancient worlds wandering in the dark. Most will never come near us, but some will, and when they do, they remind us that our solar system is not an island. We're part of a vast interconnected cosmic sea, and sometimes, just sometimes, a messenger drifts close enough to share its tale. Atlas is that messenger now, carrying with it the weight of billions of years, the memory of another place, another time, another world. And in the short span that it passes by, we are offered a glimpse into the galaxy's deep history, written not in words, but in ice, dust, and gas. When you hear the word atmosphere, you might think of Earth's blanket of air, calm and protective, or the thin veils of gases around other planets. But the atmosphere surrounding Atlas is something very different, something alive, something that behaves less like air and more like a storm. What astronomers see when they study the coma of 3I Atlas is not a passive cloud of gas just drifting through space. It's a churning, electrified plasma environment, constantly being reshaped, ripped apart, and reformed by invisible forces. It is less like a fog and more like a battlefield where solar winds collide with alien chemistry, creating spectacular effects that stretch across millions of kilometers. For a comet whose solid body is no bigger than a small city, that's nothing short of staggering. To understand why Atlas's atmosphere is so unique, you have to picture what happens when the gases pouring from its core meet the solar wind. The sun doesn't just shine light. It hurls a constant stream of charged particles across the solar system, a gale of plasma moving at hundreds of kilometers per second. When that solar wind slams into the gases surrounding a comet, it turns the coma into an electrified laboratory. Molecules are ionized, magnetic fields twist and snap, and currents ripple through the gas cloud. For most comets, this interaction is modest, a faint glow and a narrow tail pointing away from the sun. But Atlas doesn't do anything modestly. Its coma is so enormous, so filled with volatile gas, that the solar wind treats it like a planet-sized obstacle. The result is chaos, tails stretching for tens of millions of kilometers, disconnections where entire sections of the tail snap off, and a constantly shifting environment that looks less like a simple cloud and more like a storm front spreading across space. Astronomers call this kind of activity plasma physics in real time. Imagine a thunderstorm with lightning arcing across the sky and winds tearing through clouds. Only here the lightning is made of ions and the clouds stretch across distances larger than Earth itself. At times, Atlas's coma is so charged and so unstable that massive bursts of plasma are ripped away from it, forming ghostly ribbons of light that drift off into the void. To scientists, these events are invaluable because they reveal how gases and particles behave under extreme conditions. But to anyone simply hearing the story, they're nothing short of mind-blowing. A tiny rock, smaller than Manhattan, stirring up storms larger than planets. One of the most dramatic effects astronomers anticipate is called tail disconnection events. These happen when solar eruptions like coronal mass ejections slam into the comet's coma. The impact can shear off the comet's tail entirely, severing it from the coma in a sudden, spectacular act of cosmic violence. The tail then floats away, like a ghostly banner torn loose in the wind, while the comet immediately begins growing a new one. To the human eye, if you were close enough, it would look like the comet bleeding light into space, shedding a piece of itself and then regenerating it again. This cycle of destruction and rebirth is part of what makes Atlas's atmosphere feel alive, constantly responding to the moods of the sun. And with Atlas arriving during a period of heightened solar activity, the so-called solar maximum, the potential for these dramatic displays is higher than ever. Each eruption from the sun is like a hammer strike, and Atlas is the drum that resounds. The scale of this interaction is difficult to grasp. Earth's magnetic field shields us from most of the solar wind, deflecting it into beautiful auroras at the poles. Atlas has no such shield. Its gases are directly exposed, and they respond violently. The CO2-rich composition adds to the effect, because the molecules ionize differently than water. That means the plasma environment of Atlas doesn't just look bigger than normal comets, it behaves differently, in ways that even our models struggle to predict. This is one reason scientists are eager to point every instrument they can at the comet. Atlas is essentially a natural experiment, one where plasma, chemistry, and solar wind collide in ways we've never seen before. Every fluctuation in its coma teaches us something new, not only about comets, but about the fundamental physics of how gases and plasma interact in space. But beyond the science, there's the sheer spectacle of it all. Picture the comet drifting silently through the void, its tiny nucleus invisible against the blackness. Around it, an atmosphere swells outward until it dwarfs the planets, glowing faintly as sunlight scatters off dust grains and ions. From the sun's direction, streams of plasma whip against it, forcing its tail to stretch across millions of kilometers, a glowing highway of dust and gas. Then suddenly, a solar eruption tears across space, slamming into the coma with unimaginable force. The tail snaps off, severed from the comet in an instant, and drifts away like a cosmic ribbon unspooling in the dark. Minutes later, Atlas responds, spewing out fresh gas, regrowing the tail as though nothing had happened. To call it breathtaking doesn't even do it justice. It is a display of scale and violence that dwarfs anything we've ever experienced on Earth. What's especially fascinating is how this makes Atlas not just a comet, but a kind of cosmic mirror. By studying how its gases respond to the solar wind, scientists can learn more about the solar wind itself. Atlas becomes a probe, revealing details about solar eruptions, magnetic fields, and the invisible forces shaping our solar system. In this way, the comet is a teacher, as well as a traveller, showing us not only its own secrets, but the secrets of the star we orbit. And because its composition is so unusual, its interactions may reveal phenomena we've never seen before. A carbon dioxide-dominated coma colliding with solar plasma could behave in entirely unexpected ways, producing displays of light and structure that even seasoned astronomers find surprising. All of this adds to the sense that Atlas is alive. Not literally alive, of course, but alive in the way it behaves, constantly changing, constantly reacting, never the same from one day to the next. One moment it's calm, its tail stretching gently into space. The next it's erupting, spraying jets of gas, reforming its halo. Watching it is like watching a living organism breathe, grow, and adapt. For a fragment of ice and rock to exhibit such dynamism feels uncanny, almost unsettling. It reminds us that the universe isn't static, that even the smallest bodies can produce displays of power and beauty beyond comprehension. And then there's the philosophical weight of it. This comet has travelled for billions of years, silent and unseen, carrying the chemistry of a long-dead system. Now, as it passes near our sun, it lights up, its atmosphere electrified, its gases glowing, its tail whipping across the sky. For this brief moment, it becomes visible, active, alive in our eyes. It's almost as if the universe has orchestrated a performance, a final act before Atlas slips away forever. And in that act, it shows us something profound, that the cosmos is filled with hidden wonders, waiting to reveal themselves in fleeting flashes of brilliance. Atlas's electrified atmosphere is more than just a scientific curiosity. It's a reminder of scale, of beauty, of impermanence. It reminds us that even the smallest travellers can create storms larger than planets, that even the quietest wanderers can explode into brilliance when touched by light. And as we watch its tail snap, its coma glow, and its gases dance with the solar wind, we're not just observing a comet. We're witnessing a story billions of years in the making, a story told in light and plasma, a story that will never be repeated once Atlas vanishes into the dark. For scientists, it's data. For the rest of us, it's wonder. And for the universe, it's simply another reminder that even the tiniest fragments can carry the biggest truths. When astronomers plotted the orbit of 3I Atlas, their excitement quickly shifted to unease. It wasn't just that Atlas was interstellar, or that its chemistry was bizarre, or that its atmosphere was impossibly huge. It was the path it was taking. Most comets, asteroids, and planets in our solar system move in the same general direction, circling the Sun counterclockwise when viewed from above the North Pole of Earth. This common direction is called prograde motion, and it comes from the way the solar system itself formed. Billions of years ago, the planets coalesced from a giant rotating disk of gas and dust, all spinning in one direction. The result is order, a predictable traffic pattern where most bodies flow with the same current. Atlas doesn't care about that order. Its path cuts against the grain, moving retrograde, backward through the solar system, like a car driving the wrong way down a highway at full speed. This geometry makes Atlas not only unusual, but dangerous. Retrograde comets collide with the solar system's environment in a completely different way than prograde ones do. Every planet, every stream of solar wind, every magnetic field expects objects to move in a particular flow. When something comes in the opposite direction, the relative speeds of encounters skyrocket. For example, if Atlas were prograde, its velocity compared to Earth or Jupiter would be moderated, like two cars merging on the same highway. But moving retrograde, it's more like a head-on collision, the combined speeds doubling the violence of every interaction. This means every encounter Atlas has, with planets, with the solar wind, with dust streams left behind by other comets, is amplified, sharper, more chaotic. And because its orbit is also tilted in such a way that it cuts nearly along the ecliptic plane, the same plane where all the planets move, the chances for these amplified interactions are higher than they would be for a comet on a steeply inclined orbit that barely brushes the planetary paths. Atlas is, quite literally, ploughing through the busiest lane in the solar system, moving in the wrong direction and kicking up storms in its wake. This unusual geometry has already caught the attention of scientists because it promises both danger and opportunity. On the one hand, retrograde orbits increase the chances of dramatic interactions with planets. Atlas is predicted to pass near Mars, Venus, Earth, and Jupiter in the coming years, close enough for telescopes to get incredible views of its behaviour. These close passes are golden opportunities for data, because the comet's coma and tail will be stirred and reshaped by each gravitational encounter, offering glimpses into how interstellar bodies behave when subjected to planetary influence. On the other hand, those same encounters carry uncertainties. When a retrograde body passes through the inner solar system, the sheer difference in motion can produce unexpected effects, gravitational tugs that alter its trajectory in subtle ways, or interactions that trigger fresh outbursts of gas and dust. In a sense, the geometry of Atlas's orbit makes it unpredictable, forcing scientists to constantly update their models, never fully certain what it will do next. The danger isn't that Atlas will hit Earth, its path doesn't bring it that close, but that its retrograde orbit maximizes its exposure to solar wind turbulence. Every comet tail is shaped by the solar wind, but for Atlas the effect is magnified. It's colliding with the flow of plasma head-on, like a swimmer pushing against a rushing current instead of drifting with it. The result is violence. Its tail twists, bends, snaps, reforms and glows, with activity far more extreme than typical comets. This head-on geometry may be one reason Atlas's coma is so electrified and dynamic, why its interactions with the Sun look like storms instead of gentle breezes. And because the Sun is currently in its maximum activity phase, with solar flares and coronal mass ejections erupting regularly, Atlas is essentially flying into a hurricane with no shield. It's a recipe for some of the most dramatic displays we may ever witness from a comet. But the geometry doesn't just affect the coma and tail, it also affects how Atlas moves through the solar system and how we perceive it. Its retrograde motion means that, from Earth's point of view, it cuts across the sky in the opposite direction to the planets. Most celestial bodies trace arcs in one direction over weeks and months, but Atlas will move against the flow, like a character walking backward across the stage of the heavens. This makes it stand out even more to observers, a visual marker of how alien it really is. It doesn't just look strange in a telescope, it behaves strangely in every way, reminding us at every turn that it is not one of ours, not bound to our rules or rhythms. Consider, too, the long-term implications of such geometry. Retrograde comets can sometimes fragment under the stresses of their unusual orbits, especially when they pass near large planets. Jupiter, in particular, acts like a cosmic bouncer, using its immense gravity to fling comets and asteroids onto new paths or tear them apart entirely. Atlas will have a near encounter with Jupiter in its outbound journey, and scientists are watching closely to see whether that meeting will destabilize it. Will Atlas survive intact, continuing its journey into interstellar space, or will it shatter into pieces, leaving behind a trail of fragments that drift through the solar system long after the main body is gone? Either outcome would be valuable scientifically, but the drama of the latter scenario would be unmatched, a comet breaking apart under the weight of its dangerous geometry, scattering its alien chemistry across the solar system. The orbital path also makes Atlas's approach uniquely symbolic. A retrograde orbit isn't just unusual, it's rebellious. It's the mark of an outsider, an object that doesn't belong to the orderly family of planets and comets, born from the same disk of gas. Atlas comes from somewhere else, carrying with it not only different chemistry, but a different destiny. Watching it cut backward through our solar system feels like watching a visitor from another culture, one that refuses to follow our customs, blazing its own trail. There's something almost poetic in that motion, as though the comet itself is reminding us that the universe is bigger than the patterns we've come to expect, that there are other ways for worlds to form, other paths for matter to take, other stories waiting to be told. And while the geometry may seem like a cold, mathematical detail, it plays directly into the sense of awe surrounding Atlas. The retrograde orbit is part of why its interactions with the Sun are so spectacular, part of why its coma looks so stormy, part of why scientists are so fascinated by it. The geometry shapes the spectacle, and the spectacle shapes our understanding. Every twist in its tail, every flare in its coma, every unexpected outburst of gas is written by the script of its orbit. And because that orbit is so unusual, the story it writes is unlike anything we've seen before. For those watching from Earth, the thought that Atlas is moving against the flow of planets adds to its aura of mystery. It's not just a comet, it's a rebel, a traveller refusing to follow the current, daring to carve its own path. That makes it captivating not only to scientists but to anyone who gazes at the sky. In a universe that often feels predictable and ordered, Atlas is a reminder of chaos, of unpredictability, of the beauty that comes from breaking the rules. Its dangerous geometry is what makes it a threat to our models, a gift to our science, and a wonder to our imagination. And as it barrels through the solar system, cutting across planetary paths, colliding head-on with solar winds and daring gravity to challenge it, Atlas continues to prove that sometimes the most extraordinary stories are written not by what follows the rules but by what breaks them. The moment astronomers realized what they were dealing with, the phones started ringing, the emails started flying, and the global scientific community moved into action. This wasn't just another comet to file away in the endless catalogue of icy visitors. This was an interstellar traveller, a chemical anomaly, a cosmic spectacle on a scale that defied explanation. And in the world of astronomy, opportunities like this are as rare as lightning striking twice in the same place. Nobody wanted to miss it. So, around the globe, from mountaintop observatories to orbiting space telescopes, the call went out. Watch Atlas, track Atlas, measure everything about Atlas. What followed was less like routine science and more like a worldwide mobilization, an armada of instruments turning toward one tiny object in the dark, all working in unison to capture a once-in-history event. At the top of the list was the James Webb Space Telescope. Newly operational and brimming with unprecedented sensitivity, JWST is essentially the crown jewel of human astronomy. Its infrared instruments can peer into the faintest, coldest regions of the universe, detecting details invisible to any other telescope. For Atlas, this meant an unparalleled chance to study its composition. While ground-based telescopes can measure gases and dust, JWST could detect subtle chemical fingerprints in the comet's coma, revealing molecules that would otherwise remain hidden. Astronomers raced to schedule observation time, knowing that every hour spent pointing at Atlas could reveal secrets about its origin, its chemistry, and its age. For a visitor from another star system, Webb was the perfect tool, a way to look directly into its alien soul. Not far behind was Hubble, the veteran of space astronomy. Though older and less sensitive than Webb, Hubble still offers sharp optical views and the ability to track comets with incredible precision. Hubble had already proven its worth during the visits of Oumuamua and Borisov, and scientists were eager to point it at Atlas. The combination of Hubble's crisp images and Webb's deep spectra created a 1-2 punch, giving astronomers both detail and depth. Together, these two telescopes orbiting above Earth's atmosphere would deliver data no ground-based observatory could match, free from the distortions of air and weather. But the ground-based community wasn't about to be left out. From the high deserts of Chile, where the Atacama Large Millimeter Submillimeter Array, ALMA, scans the skies, to the giant mirrors of the European Southern Observatory, instruments turned toward Atlas. These facilities offered the ability to measure gases like carbon monoxide, carbon dioxide, and other volatiles at extraordinary sensitivity. For an object with such unusual chemistry, this was vital. ALMA, in particular, could detect the faintest whispers of molecules in the coma, building a chemical profile that might tell scientists where in the galaxy Atlas had formed. Meanwhile, the Keck Observatory in Hawaii and other large optical telescopes contributed high-resolution spectra, each one a line in the story of a comet unlike any other. And then there were the spacecraft already scattered throughout the solar system. Missions like the Solar and Heliospheric Observatory, SOHO, and the Parker Solar Probe, designed primarily to study the Sun, found themselves in perfect positions to observe how the solar wind interacted with Atlas's coma. For Parker, flying dangerously close to the Sun, any observations of Atlas's tail would provide front-row data on plasma physics at a scale no laboratory on Earth could replicate. Other probes, like those orbiting Mars or trailing behind Earth, were also tasked with snapping images and taking measurements as Atlas crossed their fields of view. In effect, the solar system itself became a network of observers, with every available eye turned toward this unlikely traveller. But perhaps the most inspiring part of the observing armada wasn't the giant telescopes or the billion-dollar spacecraft. It was the countless amateur astronomers who joined the chase. All over the world, from backyards to small observatories, people with modest telescopes and cameras began tracking Atlas. They shared their data online, posting images, comparing notes, and contributing to a global flood of information. In many ways, amateurs are the heartbeat of comet astronomy. They catch outbursts first, they monitor brightness changes nightly, and they provide continuous coverage that the big observatories can't. With Atlas, the amateurs became a vital part of the team. Every backyard telescope pointed skyward was another set of eyes on this once-in-history visitor, another chance to catch it flaring, fragmenting, or surprising us in ways no one expected. This global mobilization wasn't just about science, it was about urgency. Everyone knew that Atlas was temporary, a fleeting guest on a one-way trip. Its orbit meant it would never return. Its volatile nature meant it could fragment or fade without warning. And its bizarre chemistry meant every second of observation could yield data we might never see again. That urgency created a sense of unity. Astronomers from rival institutions shared data freely, pooling their results to build a clearer picture. Networks that normally competed for telescope time coordinated schedules, ensuring Atlas was covered as continuously as possible. It was as if the entire astronomy community set aside its usual rivalries and came together for a single goal: capture Atlas while we still can. For the public, this mobilization added to the sense of drama. News stories highlighted the comet's strange features, and skywatching guides showed people how to find it in their own telescopes. Social media lit up with images, fuzzy glowing blobs captured by backyard enthusiasts, alongside sharp professional photos showing the immense tail stretching across space. Each new observation added to the excitement, reminding people that this wasn't just a story for scientists, it was a story for humanity, a shared encounter with something profoundly alien. For many, it was their first glimpse of an interstellar visitor, and knowing that it would never return gave every image a bittersweet weight. Meanwhile, scientists began to compare Atlas to the previous interstellar visitors, Oumuamua and Borisov. Where Oumuamua had been too small and faint to study in detail, and Borisov had been unusual but not unrecognizable, Atlas was a gold mine. Its coma was vast, its chemistry extreme, and its orbit dangerous enough to make every observation thrilling. The data pouring in promised to rewrite models of comet behavior, planetary formation, and even galactic chemistry. By the time the observing campaign was complete, researchers knew they would be sitting on a treasure trove of information, the kind of dataset that could fuel discoveries for decades to come. Atlas wasn't just a comet, it was a once-in-a-lifetime scientific windfall. The mobilization also underscored a larger truth about humanity's place in the universe. We live on a small planet circling an ordinary star in a galaxy of hundreds of billions of stars. Most of the time, the universe feels impossibly distant, a stage too large for us to play any meaningful role, but every so often, something happens that pulls us into the story. Atlas was one of those events. It came from the depths of space, it carried the history of another system, and it passed close enough for us to study. And when it did, humanity responded with everything we had, from billion-dollar space telescopes to backyard cameras. The observing armada wasn't just a collection of instruments, it was a statement that together we are capable of reaching across the void and learning from whatever the cosmos sends our way. In the end, that's what makes this part of Atlas's story so powerful. It's not just the comet's chemistry or its orbit or its spectacular coma. It's the way it galvanized us, the way it united scientists and citizens alike in a shared pursuit of knowledge. For a brief moment, the world looked up together, and in that moment, Atlas became more than a comet. It became a symbol of curiosity, of collaboration, of the hunger to understand our place in the cosmos. Long after it vanishes into the dark, the data will remain, the images will endure, and the story will be told of how humanity, confronted with a messenger from another star, turned every lens we had toward it and listened. For all the dazzling images of Three-Eye Atlas's sprawling coma, for all the data showing its electrified atmosphere and chaotic orbit, one crucial detail continues to elude astronomers. How big is the core at the heart of it all? The nucleus is the beating heart of every comet, the solid body that anchors the show. Everything we see, the coma, the tail, the spectacular outbursts, comes from material escaping that tiny core. Yet in the case of Atlas, the nucleus remains frustratingly invisible, hidden behind the massive envelope of gas and dust it produces. Some estimates suggest it might be only a few hundred meters across, no bigger than a football stadium. Others argue it could stretch several kilometers wide, more in line with the nuclei of ordinary large comets. That uncertainty may sound trivial, but in reality it holds the key to understanding everything about Atlas, its activity, its chemistry, and its origins. The problem comes down to brightness. When astronomers measure comets, they usually separate the light of the coma from the dim reflection of the nucleus itself. By isolating the nucleus, they can calculate its size, density, and composition. But Atlas is drowning in its own brilliance. Its coma is so enormous, so luminous, that it completely swamps any signal from the core. Imagine trying to spot a candle flame behind a floodlight. That's the challenge astronomers face. Even the most powerful telescopes struggle to peer through the haze and detect the solid body at the center. As a result, every estimate of Atlas's size comes with massive uncertainties. Is it a pebble punching above its weight, or a hidden giant cloaked in gas? Right now, no one can say for sure. If the nucleus is on the smaller end, around 300 meters across, then Atlas is one of the most extraordinary objects ever observed. A body that tiny shouldn't be able to generate such a massive coma. Its surface area would be far too small, its supply of ice too limited, to sustain the outgassing required to inflate an atmosphere half the width of the Sun. And yet, if the smaller estimate is correct, that's exactly what it's doing. That would mean Atlas isn't just unusual, it's nearly impossible. It would imply that its chemistry is so volatile, its internal pressure so high, that even the smallest spark of sunlight is enough to unleash titanic amounts of gas. It would make Atlas the ultimate underdog, a cosmic minnow performing like a whale. For scientists, that scenario is both thrilling and deeply unsettling, because it suggests our models of comet behaviour are missing something fundamental. On the other hand, if the nucleus is larger, say closer to 5 kilometres across, then Atlas fits more comfortably into what we know about comets, at least superficially. A larger nucleus would provide more surface area for sublimation, more stored ices to fuel its spectacular displays. It would still be unusual, with its bizarre CO2-rich chemistry in retrograde orbit, but at least the scale of its coma wouldn't seem quite as impossible. Yet even in this scenario, Atlas doesn't stop being mysterious. Because if it is large, why does it appear so faint in direct imaging? Why is the nucleus so effectively hidden, even to instruments capable of detecting distant galaxies billions of light-years away? A larger nucleus would raise questions about the dust and crust covering it, questions about how such a body could remain invisible inside its own envelope. Either way, big or small, Atlas refuses to play by the rules. This uncertainty also ties directly into the question of how long Atlas will survive. Comets are fragile things. Many break apart after only a few close passes to the Sun, their nuclei shattered by the pressure of outgassing. If Atlas's nucleus is small, the chances of it disintegrating are high. It could fragment at any time, collapsing into a stream of rubble and gas that drifts through the solar system long after the parent body's gone. If it is larger, it might endure, continuing its one-way journey out of the solar system intact. For astronomers, the stakes are enormous. If it breaks apart, we may get a spectacular display, but much of its scientific potential will be lost. If it survives, we gain a longer window to study it. Right now, no one knows which fate awaits. The nucleus holds the answer, but the nucleus refuses to be seen. What makes the mystery even more intriguing is how it connects to the comet's chemistry. Atlas isn't just releasing water and dust like a normal comet. Its coma is dominated by carbon dioxide, a volatile far more sensitive to heat. That makes the scale of its activity hard to explain without knowing the size of the reservoir. A small nucleus with such an extreme CO2 to water ratio is a paradox. It shouldn't have enough material to maintain the outburst we're witnessing. A larger nucleus could hide vast pockets of carbon dioxide, explaining the imbalance. But again, without direct measurements, scientists are left in the dark. They have spectra, they have coma data, they have orbital dynamics. What they don't have is the solid number that ties it all together, the radius of the nucleus at the heart of Atlas. Efforts to pierce the coma are ongoing. Some astronomers are using occultations, waiting for Atlas to pass in front of distant stars. By measuring the dip in light as the coma and possibly the nucleus blocks starlight, they hope to estimate its true size. Others are using radar, bouncing signals off the comet to try to map its interior. But both methods face challenges. The coma is so dense it scatters signals, obscuring the very target scientists are trying to detect. It's a cruel irony. The very brilliance that makes Atlas so spectacular is the same brilliance that keeps its core hidden. Every new attempt feels like chasing shadows, hoping the haze will thin just enough to reveal the truth. For the public, the size of the nucleus might seem like a dry technical detail, but in reality it's the key to the entire story. If Atlas is small, it's a miracle comet, a body that defies physics as we understand it. If it's large, it's a cloaked giant, its strange chemistry rewriting the rules of how planetary systems form. Either way, it's extraordinary. And that uncertainty adds to its aura of mystery. When you look at Atlas through a telescope, you're not just seeing a comet. You're seeing a question mark, a glowing riddle wrapped in gas and light, daring us to solve it before it vanishes into the void. This puzzle also carries implications for the galaxy at large. Interstellar objects like Atlas are the only direct samples we have of other planetary systems. If its nucleus is small yet wildly active, that suggests other systems may produce comets unlike anything we've imagined. Tiny, volatile-rich fragments capable of immense displays. If its nucleus is large but hidden, that suggests alien systems may cloak their comets in strange crusts, or produce bodies with far denser outer layers than we're used to. In both cases, the message is the same. The diversity of worlds beyond our Sun is greater than we realized. Atlas isn't just one comet. It's a hint at countless others, each carrying its own secrets, each waiting to be discovered. For now, the nucleus remains the most tantalizing mystery. Every photograph, every spectrum, every data point is an attempt to peel back the layers of haze and glimpse the solid truth at the heart of the comet. But perhaps that's part of the allure. Atlas is a visitor from another star, a messenger from a world we'll never see. Maybe it's fitting that it doesn't reveal itself completely. Maybe it's meant to remain partly hidden, partly unknowable, a reminder that the universe still holds secrets we cannot yet solve. And as we watch it drift across the sky, cloaked in its glowing veil, we're left with the haunting realization that sometimes the most important truths are the ones that remain just out of sight. When astronomers began dissecting the chemistry of 3I Atlas, they expected anomalies. After all, every interstellar visitor so far has been unusual. But nothing could have prepared them for the numbers that came back from the first detailed spectroscopic analyses. Most comets in our solar system follow a rough rule of thumb: water dominates. When sunlight strikes their surfaces, frozen H2O sublimates first, forming the bulk of the coma. Other gases, carbon monoxide, carbon dioxide, methane, ammonia, are present in smaller proportions, spicing the mix but never overtaking water's role as the primary driver of activity. With Atlas, that rulebook might as well have been thrown out the window. Its coma wasn't just spiced with CO2, it was dominated by it, with ratios so extreme they bordered on the impossible. In some measurements, carbon dioxide outflow exceeded water by factors of 10, even 100, painting a picture of a comet fundamentally unlike anything born in our system. This discovery sent shockwaves through the scientific community because it cut at the heart of our assumptions about comet formation. In the cold outer reaches of the solar system where most comets originate, water ice is plentiful, and carbon dioxide is present but not in overwhelming quantities. That balance comes from the chemistry of the protoplanetary disk, the swirling cloud of gas and dust from which our sun and planets formed. If Atlas formed elsewhere, in another star system, then its extreme CO2 levels imply that its home environment was radically different. Perhaps it formed around a cooler, dimmer star where carbon dioxide could freeze more readily than water. Or perhaps it came from a system with a different chemical makeup, where carbon-rich materials dominated over oxygen-rich ones. Either way, the message was clear. Atlas is a chemical outsider, carrying the fingerprint of a world profoundly unlike our own. What makes the ratio so startling is not just the raw numbers, but the consequences they imply. Carbon dioxide is far more volatile than water. It sublimates at lower temperatures, meaning it can erupt violently even when the comet is still far from the sun. That volatility explains why Atlas lit up so spectacularly while still out past Mars, inflating a coma half the size of the sun long before ordinary comets would have shown visible activity. But it also raises troubling questions. If Atlas is expelling carbon dioxide at such a staggering rate, how much of it is stored within? How long can it sustain this frenzy before exhausting its reserves? Is the comet hollowing itself out, burning through its volatile layers so quickly that it risks collapsing into rubble? The impossible ratio isn't just a curiosity, it's a ticking clock, a clue that Atlas may be living fast and dying young. This imbalance also reshapes the way astronomers think about the physics of the coma itself. In water-dominated comets, sublimation is a relatively steady process. The sun heats the nucleus, water turns to vapor, dust is lifted, and the coma forms in predictable patterns. With carbon dioxide, the process is wilder. CO2 gas expands more violently, blasting out jets that tear through the surface and fling dust into space at higher speeds. That may be why Atlas's coma appears so turbulent, with arcs, spirals, and chaotic plumes rather than smooth outflow. It's less a gentle evaporation and more a series of explosions, like geysers roaring into the void. This violent behavior helps explain the comet's immense scale, but it also deepens the mystery. What kind of internal structure could survive such relentless pressure without shattering? And how could a nucleus, perhaps only a kilometre or two wide, contain so much volatile gas without blowing itself apart entirely? The implications stretch even further. If Atlas is typical of comets from its home system, then that system must be chemically exotic, a place where carbon dioxide was not just abundant but dominant during planetary formation. That opens tantalizing possibilities. Maybe it orbited a star with a different balance of carbon and oxygen in its protoplanetary disk. Maybe it formed in the outer zones of a red dwarf system, where temperatures were low enough to trap CO2 as ice, while water remained scarce. Or maybe it originated in a massive stellar nursery, where radiation fields altered the chemistry of forming bodies, seeding them with unusual volatiles. Whatever the case, Atlas is more than a comet. It's a messenger, carrying a chemical fingerprint of a world we will never see, a world written into the ratios of its gases. For scientists, this is gold. By studying Atlas's coma, they can glimpse the diversity of planetary systems across the galaxy. Until recently, our understanding of exoplanets and their environments came mostly from telescopes measuring atmospheres and orbital dynamics at vast distances. But Atlas is a piece of that puzzle delivered to our doorstep, tangible and measurable. Its impossible CO2 ratio is a direct sample, proof that other systems follow different rules, and that means the galaxy is far stranger and more varied than we dared to imagine. If one star system can produce a comet like Atlas, how many others are out there, waiting to surprise us with chemistries we can't yet conceive? The CO2 mystery also fuels speculation about Atlas's age. Carbon dioxide is volatile. Over billions of years, most reservoirs should have been depleted either by stellar radiation or cosmic rays. For Atlas to carry such an abundance, it must have been preserved in deep cold for eons, locked away in the outer reaches of its home system before being ejected. That suggests Atlas is ancient, perhaps older than our Sun itself, a relic from the earliest days of galactic history. Every molecule of carbon dioxide spilling from its coma may have formed in a disk long vanished, orbiting a star whose light will never reach us. In that sense, Atlas is not just a comet, it's a time capsule, venting gases that predate the solar system, carrying whispers of a cosmic dawn. And yet, the impossible ratio may also spell doom for Atlas. If its activity is truly dominated by CO2, then its structural integrity is at risk. The violent jets could fracture the nucleus, tearing it apart as internal pressure overwhelms gravity and cohesion. Many comets meet their ends this way, fragmenting into streams of rubble that scatter across the solar system. For Atlas, the risk is amplified by its bizarre chemistry. Every jet is a stress test, every outburst a gamble. One wrong eruption, one fracture too deep, and the entire body could shatter. If that happens, its mystery will scatter with it, leaving us only fragments to study, tantalizing pieces of a riddle we never fully solved. For the public, the CO2 story adds drama to the spectacle. It's not just a glowing smear in the sky. It's a cosmic soda bottle shaken and opened in space, fizzing out gases at impossible rates. It's a comet that defies the rules, a body that refuses to be ordinary. Its impossible ratio gives it a personality, volatile, unpredictable, alive with chemical fury. And knowing that those gases carry the fingerprint of another world makes the story even richer. When you look at Atlas, you're not just seeing a comet. You're seeing the exhalation of an alien star system, molecules frozen billions of years ago now rushing into the void, visible to human eyes for the first and only time. Ultimately, the impossible CO2 to water ratio is the heart of Atlas's mystery. It's the number that refuses to fit, the clue that changes the story, the revelation that elevates it from comet to enigma. And whether it's a tiny nucleus somehow sustaining impossible activity, or a larger body cloaked in dust and ice, the ratio insists that Atlas is not like anything we've seen before. It is a visitor from another world, carrying secrets in its breath, daring us to learn what we can before it vanishes forever. The more we measure, the stranger it becomes. And that strangeness is the gift. Atlas teaches us that the universe is broader, more diverse, and more astonishing than our narrow models predict. Its impossible ratio is not a flaw, it's a message written in carbon and ice, whispered across light years, and briefly illuminated by the touch of our sun. From the moment astronomers first noticed Atlas glowing more brightly than its size should allow, whispers of its fragility spread through the community. Comets are notorious for crumbling under pressure, their loosely bound mixtures of ice and dust more like cosmic snowballs than solid rocks. Even in our solar system, countless comets have met their ends by shattering into fragments, torn apart by their own outgassing or by the tidal grip of planets and the sun. But with Atlas, the threat of disintegration looms even larger, magnified by its impossible chemistry, its violent retrograde path, and the sheer chaos of its activity. If ever there were a comet destined to self-destruct in spectacular fashion, it is this one. The seeds of destruction lie in Atlas's volatile nature. As established, its coma is dominated by carbon dioxide, a gas that sublimates explosively even at great distances from the Sun. Every burst of CO2 is like a rocket engine firing from beneath the surface, blasting material into space with tremendous force. These jets don't emerge evenly. They carve fissures, gouge vents, and create imbalances in the nucleus. Over time, those imbalances accumulate, building stresses that no fragile cometary body can withstand forever. Imagine a balloon with too many weak spots. Sooner or later, one puncture will cause the entire structure to rip apart. For Atlas, that balloon is stretched taut, its fragile frame straining against internal forces it may not survive. Cometary breakups are not rare. The history of astronomy is littered with examples. Shoemaker-Levy 9, torn to pieces by Jupiter's gravity in 1992, before crashing spectacularly into the planet 2 years later. Comet Eson, which disintegrated in 2013 as it passed too close to the Sun. Even Comet 73 Persei Schwarzmann-Wachmann, which fragmented into dozens of smaller bodies visible from Earth. These events remind us that comets are ephemeral, fragile and prone to collapse. But Atlas is no ordinary comet. Its extreme activity suggests that the forces tearing at its nucleus are far greater than usual. If it does fragment, the result could be unlike anything we've ever seen. A catastrophic unspooling of an interstellar visitor, scattering alien material across the solar system in a cosmic fireworks display. The danger isn't just internal pressure. Atlas's orbit increases the likelihood of stress from external forces as well. Its retrograde path brings it into direct headwinds of solar wind and radiation, forces that slam into its coma with magnified violence. Each solar storm, each coronal mass ejection, strikes Atlas harder than it would a prograde comet, intensifying the turbulence in its atmosphere. These interactions ripple back to the nucleus, shaking it like a drum. If the comet's internal structure is weak, if it's riddled with voids, fractures, or fragile layers of ice, those constant shocks could be enough to destabilize it. Add to this the gravitational tugs from close planetary encounters in the coming years, and Atlas becomes a body under siege, bombarded from within and without, every force conspiring to tear it apart. If Atlas does fragment, the process could unfold in different ways. One possibility is a gradual shedding of pieces, with small fragments breaking away from the main nucleus, each trailing its own miniature coma. To telescopes, this would look like the comet sprouting companions, tiny glowing dots drifting alongside it. Another possibility is a sudden, catastrophic breakup, where the nucleus disintegrates in a matter of hours or days, releasing a torrent of dust and gas into space. In that scenario, the once solid heart of Atlas would vanish, replaced by a diffuse cloud spreading across millions of kilometers. To the naked eye, it might appear as a sudden brightening followed by a rapid fading, a cosmic spark flaring and then extinguishing as the pieces disperse. Either way, the event would be unforgettable, a final act written in fragments and light. For scientists, the prospect of fragmentation is bittersweet. On one hand, breakups provide invaluable data. Each fragment exposes fresh interior material, untouched since the comet's formation. By analysing the gases and dust from these pieces, astronomers can glimpse deeper layers of the nucleus, unlocking secrets hidden beneath the surface. Breakups also allow scientists to study the mechanics of cometary failure, revealing how fragile bodies respond to pressure, heat, and stress. In that sense, Atlas's potential destruction would be a scientific windfall, a chance to peer inside an interstellar object in unprecedented detail. On the other hand, fragmentation complicates observation. Once the nucleus is gone, there's no longer a coherent body to track. The comet becomes a cloud, difficult to measure, its story harder to piece together. For those hoping to follow Atlas's journey into interstellar space, fragmentation would be a frustrating end. The public, however, would see it differently. To skywatchers, a breakup would be pure spectacle. Imagine looking through a telescope and seeing not one comet but a swarm of glowing shards, each carrying its own ghostly trail. Imagine watching as the sky suddenly brightens, as Atlas's coma swells with fresh material, as its tail twists into chaotic shapes. For a few nights, the event could rival the greatest cometary displays in history, a once-in-a-lifetime light show visible across the globe. It would be tragic to lose the comet's nucleus, but unforgettable to witness the drama of its demise. In a way, Atlas's breakup would be the ultimate embodiment of its story: brief, brilliant, and utterly unrepeatable. But perhaps the most haunting aspect of fragmentation is what it symbolises. Atlas is already unique, a rebel on a retrograde orbit, a body with impossible chemistry, a messenger from another star system. If it disintegrates, it becomes even more ephemeral, a reminder of the impermanence of cosmic wonders. We would be watching the literal unravelling of an alien world, a body that has travelled for billions of years only to dissolve in the light of our sun. It's almost poetic, a visitor that burns brightly, teaches us everything it can in a fleeting moment, and then vanishes forever, leaving only memories and data in its wake. For all our science, for all our telescopes and instruments, we would be powerless to stop it, witnesses to a cosmic truth that nothing lasts forever, not even travellers older than our solar system. Speculation about Atlas's fate is already fueling debates among astronomers. Some argue that its activity is too extreme to sustain, that it will fragment within months or years. Others point to its resilience so far, noting that despite violent outbursts and solar storms, it continues to hold together. Perhaps its nucleus is stronger than we think, its structure more robust, its chemistry more balanced. Perhaps it will endure, surviving its perilous journey and slipping quietly back into interstellar space, leaving us to wonder what might have been. Either way, its fate will be decided not by us, but by the hidden structure of its core, by fractures we cannot see, by forces playing out far from human control. All we can do is watch, and that, in the end, is what makes the prospect of fragmentation so compelling. It's not just a scientific puzzle or a visual spectacle, it's a story, one that resonates with the human condition. Atlas is fragile, like us. It is temporary, like us. It shines brightly for a moment and then fades, like us. To watch it teeter on the edge of survival is to glimpse something profound about existence itself, that even the grandest travellers can be undone by their own fragility, that even the most ancient wanderers can crumble into dust. Atlas's potential breakup is more than a prediction. It's a metaphor written across the sky, reminding us that impermanence is universal, that every story has an ending, and that sometimes the ending is as beautiful as the beginning. When historians of astronomy look back on the early 21st century, the story of Three-Eye Atlas will stand as one of the defining chapters in our understanding of interstellar visitors. For centuries, comets were mysterious wanderers, often feared as omens, later understood as icy relics from the birth of the solar system. But only recently have we realised that not all comets are local. Some come from far beyond, crossing light years of empty space to briefly pass through our celestial neighbourhood. First came Oumuamua, a sliver of rock so strange it defied every expectation. Then Borisov, more comet-like but still unusual. And now Atlas, the third and most spectacular, rewriting the rules with every observation. Together, these three have cracked open the door to a new era of astronomy, one where interstellar visitors are no longer curiosities, but vital messengers from distant stars. And among them, Atlas stands out as the comet that changed everything. The legacy of Atlas begins with its sheer scale. By inflating a coma half the width of the Sun, it forced astronomers to rethink what small bodies are capable of. A nucleus possibly no larger than a city block should never have been able to produce an atmosphere so massive, yet Atlas did. That contradiction between small body and colossal presence will linger long after the comet itself is gone. It challenges our models of sublimation, of chemical storage, of structural stability. It shows us that size is not always destiny, that even the smallest fragments can exert an influence far beyond what physics predicts. In that sense, Atlas is a lesson in humility, a reminder that the universe holds surprises that defy our equations. But Atlas's legacy goes deeper than scale. Its bizarre chemistry, dominated by carbon dioxide instead of water, reveals just how diverse planetary systems can be. In our solar system, comets reflect the conditions of the protoplanetary disk that birthed them: water-rich, oxygen-balanced, structured in predictable gradients of temperature and ice. Atlas is proof that other systems follow different rules. Perhaps its parent star was cooler, locking in carbon dioxide where water remained gaseous. Perhaps it formed in a chemically carbon-rich region, skewing the balance of volatiles. Whatever the case, Atlas carries a fingerprint of another world, one we will never see directly. Its gases are the breath of an alien system, vented into our skies. By analysing them, we glimpse not just one comet but the diversity of entire galaxies, a kaleidoscope of planetary chemistries far richer than we once dared imagine. That legacy of diversity, of chemical plurality, will fuel theories of planet formation for decades. Atlas also leaves behind a legacy of fragility, its potential to fragment, its unpredictable activity, its volatility, all highlight the impermanence of these visitors. Interstellar objects are ancient travellers, perhaps billions of years old, but their moment in the sun is brief. They flare brightly, teach us what they can, and then either vanish or disintegrate. Atlas embodies this fleeting nature more vividly than any comet before it. Its entire story is one of extremes, born in another system, hurled across light years, lighting up spectacularly, threatening to shatter at any moment. For scientists and skywatchers alike, it is a reminder that the cosmos is filled with wonders that appear once and never again. Its legacy will be one of urgency, to seize every chance, capture every bit of data, before the moment is gone forever. Another part of Atlas's legacy lies in the way it united humanity's instruments into an unprecedented observing campaign. From the James Webb Space Telescope to backyard telescopes, from orbiting spacecraft to radio arrays, the world mobilized to study this comet. That global effort reflects a new model for astronomy, one built on collaboration and speed. Interstellar visitors don't wait for our schedules. They arrive unannounced, stay briefly, and depart forever. Atlas forced the scientific community to act quickly, to share data openly, to coordinate across borders. That urgency created a template for the future. When the next interstellar object arrives, we will be ready, not scrambling to organize, but prepared with protocols forged in the fire of Atlas's fleeting passage. In that sense, Atlas leaves behind not just data but a new way of doing science, one that values speed, cooperation, and inclusivity. For the public, the legacy of Atlas is awe. It reminded people everywhere that the universe is not static but alive with visitors, travellers from far-off systems appearing in our skies. The images of its immense coma, the stories of its strange chemistry, the speculation about its fate, all of these captured imaginations far beyond the world of science. In classrooms, in news reports, in backyard star parties, Atlas became a story of wonder. For a generation of young observers, it may be their first memory of an interstellar comet, a spark that ignites a lifelong fascination with the cosmos. Its legacy is not just scientific, it is cultural, inspirational, a reminder that even in a world crowded with screens and distractions, the sky can still command our attention. Atlas's legacy also connects to the question of life. The chemistry of comets has long been linked to the origins of life on Earth, with some scientists proposing that comets delivered the water and organic molecules that seeded the planet. If Atlas carries the chemistry of another system, then it carries the possibility of other recipes for life. Its carbon dioxide dominance suggests different balances of volatiles, perhaps different pathways for organic synthesis. By studying it, we expand our understanding of what conditions might support life elsewhere in the galaxy. Atlas reminds us that Earth is not the template for everything. Life may emerge in environments we would consider alien, nurtured by chemistries that look impossible to us. Its legacy, then, is not just about comets. It is about possibility, about opening our minds to forms of life and worlds that defy our expectations. And then there is the philosophical legacy. Atlas is a traveller from beyond, older than our solar system, carrying the history of a place we will never visit. To see it flare in our skies is to be reminded of the vastness of time and space, of the countless stories unfolding beyond our reach. Atlas will leave, but others will come. Each one will carry its own mysteries, its own chemistry, its own lessons. Together, they remind us that the galaxy is not a distant abstraction, but a living community of worlds, some of which occasionally send their emissaries our way. Atlas is part of that dialogue, a conversation between stars written in ice and light. Its legacy is that of a messenger, bridging the gap between systems, reminding us that we are part of something immeasurably larger. In the end, Atlas's legacy is multifaceted. It is scientific, reshaping our models of comets and planetary systems. It is cultural, inspiring awe and wonder in millions of people. It is philosophical, reminding us of our place in the cosmos. And it is practical, forging new methods of collaboration and observation for the discoveries yet to come. Long after its coma fades, long after its nucleus shatters or vanishes into the dark, Atlas will endure in our records, in our stories, in our imaginations. We will remember the comet that defied the rules, the visitor that lit up our skies, the messenger that carried secrets from another world. And in that memory, Atlas achieves a kind of immortality, not in the stars, but in us. As Atlas drifts farther from the sun, its brilliance begins to wane. The great coma that once stretched wider than the sun itself starts to shrink. The furious outbursts of carbon dioxide slow, and the storm of activity quiets. In time, the comet will fade from our view entirely, retreating into the cold and empty dark beyond the reach of human eyes. For most comets, this is the natural arc, a brief spectacle, a moment of wonder, and then silence. But Atlas is not most comets, and its story will not fade so easily. What it leaves behind is not just a trail of dust, but a legacy of questions, discoveries, and reflections that will linger for decades, perhaps even centuries. In many ways, the comet itself is gone long before it leaves us. What remains is the mark it has carved into our understanding of the cosmos, and into our sense of wonder. Atlas's story began in another star system, perhaps billions of years ago, somewhere in a disk of gas and dust not unlike the one that gave rise to our sun. Ice is condensed, fragments collided, and a small, volatile-rich body took shape. For eons it wandered the outer reaches of its home, preserved in deep cold, until a gravitational nudge sent it careening into interstellar space. It drifted for countless ages, alone in the void, crossing gulfs of darkness we can barely imagine. And then, by chance, it encountered our solar system, slipping into the light of our sun. That moment of encounter transformed it, turning a silent traveller into a luminous spectacle, a messenger that demanded attention. Its passage through our skies was brief, but in that moment it carried with it the weight of a journey older than humanity itself. What makes Atlas unforgettable is the way it broke every rule. Its retrograde orbit challenged the order of our solar system, a rebel cutting across the planetary lanes in defiance of the ancient disk that shaped our worlds. Its chemistry shocked astronomers, a coma dominated not by water, but by carbon dioxide, a volatile signature alien to our familiar comets. Its scale defied comprehension, a nucleus smaller than a city block inflating an atmosphere wider than the sun. Each of these anomalies alone would have made Atlas a comet worth remembering. Together, they created an enigma, a riddle wrapped in gas and light, daring us to explain it. And though we learned much, the full truth remains elusive. Perhaps it always will. Atlas reminded us that the universe is not obligated to fit our models. Sometimes it offers mysteries we cannot solve, only marvel at. But the true power of Atlas lies not only in its strangeness, but in the way it changed us. It galvanized the global scientific community, uniting telescopes, spacecraft, and amateurs into an armada of observation. It inspired awe in the public, rekindling the age-old fascination with comets as harbingers of wonder. It reminded us that the galaxy is not distant and abstract, but alive with visitors, emissaries from other stars that pass through our skies and invite us to look upward. In an age often consumed by the noise of daily life, Atlas offered a rare moment of perspective. It reminded us that we are part of something vast, that the universe is larger and stranger than we can grasp, and that even the smallest fragment of ice and dust can carry messages written across light years. The philosophical weight of Atlas's story cannot be overstated. It is a tale of impermanence, of brilliance born from fragility. Comets are transient things, easily destroyed, easily forgotten. Atlas embodied that transience more than most, threatening to fragment at every moment, glowing fiercely only to fade again. Its story is our story, brief, fragile, luminous. Like Atlas, we are small bodies in a vast universe, flaring briefly in the light before vanishing into the dark. And yet, like Atlas, we can leave a mark, The comet's gases told us of another world. Its orbit reminded us of cosmic diversity. Its spectacle inspired millions. In the same way, our lives, though brief, can carry meaning far beyond their scale. Atlas is a mirror, reflecting back the truth of our own existence in the language of stars and ice. For scientists, Atlas leaves behind a trove of data that will take years to unravel. Its chemical ratios, its volatile behaviour, its plasma interactions, each holds clues about planetary formation, about interstellar chemistry, about the nature of comets themselves. The debates will continue. Was the nucleus truly as small as some believe, or larger than we imagined? Did its carbon dioxide dominance reveal a unique birthplace, or simply a rare combination of circumstances? Will future visitors resemble Atlas, or was it an outlier, a singular wonder never to be repeated? These questions ensure that Atlas's influence will not fade. It will echo in papers, in conferences, in models of planetary systems across the galaxy. Long after the comet itself is gone, the science it inspired will continue to shape our understanding. For the rest of us, Atlas leaves behind something less tangible, but no less real, a sense of wonder. It is easy to forget in the rush of daily life that we live in a universe filled with mysteries. But every so often the sky reminds us. A comet flares, a star explodes, a visitor drifts across the heavens, and we are compelled to look up. Atlas was one of those reminders, a moment when the cosmos tapped us on the shoulder and whispered, "There is more. More to see, more to learn, more to imagine." And that whisper, once heard, cannot be forgotten. It lingers, shaping the way we see the world, reminding us that wonder is always above us, waiting. As Atlas fades into interstellar space, it carries with it the unanswered questions and unresolved mysteries it gifted us. Perhaps, in another corner of the galaxy, someone else will see it, another civilization looking upward as we did, marvelling at its scale, puzzled by its chemistry, inspired by its presence. Perhaps Atlas's journey is not just a message for us, but for many, a thread weaving together distant worlds in shared wonder. We will never know, but the thought is enough. It reminds us that the cosmos is not ours alone, that the stories it writes may echo across civilizations, binding us together through the language of light. In the end, Atlas is more than a comet. It is a story of travel, of transformation, of brilliance and fragility, of questions and wonder. It is a reminder that the universe is alive with travelers, that the boundaries between stars are not empty, but filled with motion, with history, with surprise. Atlas came to us briefly, burned brightly, and left. But in its brief visit it changed us. It expanded our science, deepened our wonder, and reminded us that the cosmos is vast beyond imagination. That is its final legacy. Not the coma, not the tale, not even the data, but the wonder it left in its wake. A wonder that will endure long after the comet itself is gone, as long as humanity continues to look upward and ask questions. Atlas fades, but the questions remain. And in those questions lies the true brilliance of its story. The story of Three-Eye Atlas does not end when its light fades from our skies. In truth, the comet's greatest journey begins the moment it leaves our field of view. For as Atlas drifts back into the darkness between the stars, it carries with it a new kind of immortality, not in its fragile nucleus or transient tail, but in the minds and hearts of those who observed it. Every telescope that tracked its course, every spectrum that captured its gases, every photograph that froze its ghostly form against the heavens is part of a legacy that will outlive the comet itself. Atlas is not simply an object anymore. It has become a symbol, a marker in the history of discovery, a chapter in the story of humanity's growing awareness of the universe. And as with all great symbols, its meaning stretches far beyond the details of its chemistry or orbit. Atlas stands as a reminder of what it means to be curious in a cosmos so vast and so old that it humbles us at every turn. To understand why Atlas matters so profoundly, we must place it in the lineage of other celestial messengers. Humanity's relationship with comets has always been complicated. In ancient times, they were feared as omens of doom, fiery apparitions streaking across the sky with no regard for human order. Later, as science advanced, they became subjects of fascination, their elliptical orbits proving the clockwork of the heavens, their icy composition suggesting origins in the far reaches of our system. But Atlas carried that relationship to an entirely new level. It was not born here. It did not follow the paths of Halley, Hale-Bopp, or Encke. It came from the beyond, and in that fact lies its true power. For the first time, people could look up and know that they were seeing not just a relic of our own sun's formation, but a fragment of a different world, a piece of a different history. That realization is transformative. It shifts the conversation from what our system is like to what the galaxy is like. It makes the sky bigger, the universe richer, the mystery deeper. And yet, despite its foreign origin, Atlas felt strangely familiar. It glowed like our comets do, sprouted tails like our comets do, behaved unpredictably like so many of our comets do. It was alien and yet relatable, distant and yet intimate. That paradox speaks to a larger truth about the cosmos, that despite the unimaginable diversity of worlds, there are common threads that bind them. Gravity pulls on all things. Chemistry shapes them in recurring patterns. Light reveals them when they approach a star. In Atlas, we saw both the foreign and the familiar, the exotic and the universal, and in that duality we saw a reflection of ourselves, small beings on a small world, but made of the same matter that flows across the galaxy, bound by the same forces, illuminated by the same light. This duality is what makes Atlas's legacy so rich. On the one hand, it deepens our scientific knowledge. Every measurement of its CO2, every calculation of its orbit, every attempt to constrain its nucleus size pushes the frontier of what we know about interstellar bodies. On the other hand, it deepens our philosophical imagination. It invites us to wonder what other star systems might be like, what other comets might carry, what other travellers might appear in our skies. It opens a door not just to knowledge but to curiosity, to dreaming. And that, perhaps, is the greatest gift of all. Not answers, but questions. Atlas reminds us that the universe is not a solved puzzle, but a living mystery, one that constantly surprises us, one that resists closure. In a world that often seeks certainty, Atlas gave us something more precious, the unknown. The comet also forces us to reflect on time. Its journey likely took millions, even billions of years, a span so vast it dwarfs human history. Every civilization that has ever existed, every story ever told, every life ever lived, all of it unfolded while Atlas drifted silently through the void, long before it came close enough for us to notice. And now, for a brief flicker, our paths crossed. We saw it, measured it, spoke of it, told stories about it, and then it was gone. That fleeting intersection is poignant, a reminder of how small we are in the flow of cosmic time, but also how privileged we are to live in an age when we can recognize such events for what they are. To ancient peoples, Atlas would have been a portent. To us, it is a data point, a clue, a messenger. That evolution in perspective is itself part of its legacy. We are no longer afraid of the sky. We are students of it, listeners to its messages, interpreters of its signs. Atlas came to us not as a threat, but as a teacher, and that marks a profound shift in the story of our species. And what of the future? Atlas will fade into the dark, but it will not be the last interstellar visitor. Others will come. Some may be faint and elusive, barely detectable specks slipping past unnoticed. Others may blaze as brightly as Atlas, drawing the attention of the entire world. Perhaps one day, we will even send spacecraft to intercept one, to sample its surface, to carry pieces of alien worlds back to Earth. When that day comes, it will be because comets like Atlas prepared us, scientifically, technologically, and emotionally for the possibility. Its legacy is not just in the past, but in the future it makes possible. The missions it inspires, the discoveries it foreshadows. We stand at the threshold of a new era, one where the galaxy comes to us in the form of wandering fragments. Atlas was one of the first, but not the last. For all of its strangeness, Atlas also leaves behind something profoundly human, a sense of story. We are storytellers by nature, weaving meaning from events, drawing connections between past and future. Atlas gave us a story rich in drama, filled with mystery, lit with wonder. It was a story of extremes, a nucleus so small, a coma so vast, a chemistry so bizarre, a beauty so familiar, a journey so ancient, a moment so fleeting. It was a story of survival, of fragility, of transformation. And like all good stories, it left us changed. We may forget the technical details, the ratios of gases, the specifics of its orbit. But we will not forget the feeling it gave us, the sense of standing at the edge of something larger than ourselves, the awe of seeing an alien wanderer flare in our skies, the humility of knowing it will never return. That feeling is the true legacy, the story that will be told and retold, each time reminding us of the cosmos we inhabit. As the last traces of Atlas fade, we are left with a choice. We can treat it as a curiosity, file it away, and move on. Or we can treat it as an invitation to look up more often, to wonder more deeply, to remember that the universe is alive with visitors and surprises. Atlas cannot choose what it leaves behind, but we can choose how we carry it forward. If we carry it as inspiration, as motivation, as a spark for new science and new wonder, then Atlas will never truly be gone. It will live on in our questions, in our explorations, in our dreams. So perhaps that is the final meaning of Atlas. Not just a comet, not just a messenger, not just a spectacle. It is a reminder that we are participants in a larger story, one that stretches across stars and epochs, one that binds us to the cosmos in ways we're only beginning to understand. Atlas came, it shone, it left, and in its wake it left us changed, not because of what it was, but because of what it revealed, that the universe is vast, strange, and endlessly full of wonder, and that in the face of such enormity, our best response is not fear, but curiosity. Long after Atlas has slipped from sight, its ghost remains in the minds of those who studied it, those who photographed it, and those who simply looked up at the sky and knew something extraordinary was happening. The comet is gone, but the imprint it left on human imagination lingers, as persistent as the dust trails comets leave behind in space. Atlas was never meant to stay. Its entire existence in our skies was defined by transience. And yet, by appearing when it did, behaving as it did, and dazzling us with mysteries we cannot fully solve, it gave us a story larger than itself, a story about what it means to be temporary in a universe that endures. The first lesson of Atlas's epilogue is scale. In every sense, it forced us to grapple with magnitudes that defy our intuition. A nucleus no bigger than a city block, exhaling gases until it produced a coma larger than the sun. A retrograde orbit slashing against the natural flow of the solar system, accelerating encounters into near collisions of unimaginable energy. A chemical ratio so bizarre it hinted at star systems utterly unlike our own. Atlas's life in the spotlight was a masterclass in disproportionality, in how the smallest seeds can produce the largest consequences. That lesson applies as much to humanity as it does to astronomy. We too are small bodies on a small planet, yet capable of shaping futures, of altering worlds, of creating legacies far beyond our size. In Atlas's scale we see reflected our own paradox, tiny yet significant. The second lesson is impermanence. Atlas was fragile, perhaps the most fragile interstellar traveller we have yet seen. It threatened to fragment at every turn, and perhaps even now, as it drifts farther from the sun, its nucleus is fracturing quietly into pieces too small for us to see. And still, for that brief intersection with our skies, it shone brilliantly. That transience is its truth. Beauty born from fragility, wonder born from vulnerability. Comets remind us that even the oldest travellers are temporary, and Atlas carried that message more clearly than most. Its impermanence forces us to face our own, to understand that our brilliance, too, may come not in permanence but in the fleeting intensity of our moments. What matters is not how long we endure, but how brightly we shine while we are here. The third lesson is mystery. Atlas left us with more questions than answers. Was its nucleus small or large? Why was its chemistry dominated by CO2? How did it survive such violent activity without disintegrating? These questions will fuel debates and studies for years, but perhaps they are not meant to be fully answered. Perhaps Atlas's true gift was to remind us that not everything can be solved, that some mysteries are meant to expand our wonder rather than close it. We live in an age that prizes certainty, but certainty can sometimes blind us to possibility. Atlas teaches that mystery is not failure, it is invitation. An invitation to imagine, to speculate, to dream of what other travellers might be like, of what other stories might cross our skies. Its legacy is not closure but curiosity. The fourth lesson is connection. Atlas united us. From billion-dollar space telescopes to backyard observers with modest lenses, the world turned its attention upward. For a brief time, humanity was aligned in focus, not on conflict or division, but on wonder. Scientists shared data across borders, amateurs posted images across continents, strangers looked at the same sky and felt the same awe. In that shared moment, Atlas reminded us of something essential, that we are one species under one sky, united not by answers but by questions. Every interstellar visitor carries this potential, to pull us out of ourselves, to show us that our divisions are trivial compared to the vastness above. Atlas fulfilled that potential magnificently, leaving behind not just data but unity, however fleeting. And finally, Atlas's epilogue offers hope. It is easy, in a world filled with uncertainty and turmoil, to forget that wonder still exists. But every so often, the universe reminds us. A star explodes, a planet aligns, a comet blazes across the sky. These events are gifts not because they solve our problems, but because they remind us of perspective. They remind us that beyond our struggles lies a cosmos vast and alive, a stage so grand it humbles and uplifts us at once. Atlas was such a gift. It did not stay long. It did not give us certainty, but it gave us perspective, and with perspective comes hope. The hope that there is more to see, more to learn, more to marvel at. So what happens now? Atlas continues its journey, slipping back into the cold between stars. Perhaps it will survive intact, carrying its strange chemistry across light years, waiting for another star to awaken it millions of years from now. Perhaps it will fragment, scattering its material into a diffuse cloud that will drift unseen forever. Either way, its story continues, far from us, written in the quiet language of ice and dust. We will not see the rest of that story, but that does not diminish its meaning. Our role was never to own Atlas, only to witness it, and in that witnessing, we became part of its journey, part of its legacy, part of its message. In the centuries to come, Atlas will be remembered as one of the first interstellar visitors to teach us about the diversity of worlds beyond our sun. It will be cited in papers, referenced in lectures, used as a case study in the strangeness of planetary systems. But beyond the science, it will be remembered in stories. The story of the comet that defied the rules, the comet that united the world, the comet that carried secrets from another star. And perhaps, in some distant future, when humanity itself becomes interstellar, travelling to other systems and studying their comets firsthand, Atlas will be remembered as a foreshadowing, a messenger that told us, long before we left Earth, that the galaxy is full of wonders waiting to be found. For now, all we can do is look up and remember. Remember the nights when Atlas blazed in the sky. Remember the strange ratios, the massive coma, the fragile nucleus. Remember the feeling of seeing something not of this world, something older than our sun, something fleeting yet unforgettable. Remember that wonder is always there, waiting above us, waiting for us to notice. Atlas fades, but the memory does not. The questions do not. The wonder does not. And as long as we carry those with us, the comet will never truly be gone. In the silence after its passing, Atlas leaves us with one final truth, that the universe is not static but alive, not empty but filled with travellers, not finished but unfolding. We are part of that unfolding, part of that story. And just as Atlas passed through our skies, we too pass through the cosmos, brief and brilliant, fragile and luminous, here for a moment and gone again. To see Atlas is to see ourselves, to know that our stories too are fleeting, but that fleeting does not mean meaningless. Fleeting can be beautiful. Fleeting can be unforgettable. Fleeting can be everything. The journey of 3i Atlas is one of those rare cosmic events that reminds us why we look up at the night sky in the first place. From the moment it burst into view, far brighter and far stranger than its small size should have allowed, it captured both the scientific community and the imagination of millions of ordinary skywatchers. It came to us as a mystery, a rebel on a retrograde orbit, carrying with it chemical signatures unlike anything we had seen before, and it leaves us as a symbol, a messenger, and a question that may never be fully answered. Its enormous coma, its violent jets of carbon dioxide, its threat of fragmentation, and its potential to disappear just as suddenly as it appeared, all of these made Atlas a fleeting wonder, a reminder that the universe is not static but alive with travellers, emissaries from other stars that cross our skies without warning. The comet's scientific importance cannot be overstated. Every reading of its gases, every analysis of its spectrum, every attempt to understand how something so small could create something so vast will shape the way we think about planetary systems beyond our own. Atlas showed us that worlds can form with chemistries wildly different from our own solar system, that even fragile fragments can survive journeys across interstellar space, and that the rules we think we know are always waiting to be rewritten. It reminded us that we're still at the beginning of understanding how common these visitors might be, and how much they can teach us if we are ready to study them quickly and carefully. But beyond the data, Atlas's story resonates because it speaks to something deeply human. Its fragility mirrors our own. Its brilliance, despite that fragility, mirrors our potential. Its fleeting passage through our skies mirrors our fleeting passage through time. In Atlas, we see ourselves, small, fragile, temporary yet capable of brilliance, of wonder, of leaving behind a story larger than our scale. The comet becomes more than an object. It becomes a metaphor, a reflection, a reminder that impermanence does not diminish meaning. If anything, impermanence is what makes meaning possible. And perhaps that is the final gift of Atlas, not just the science, not just the spectacle, but the perspective. For a brief time, it united people across the world, pulling our gaze upward, away from daily noise and distraction, toward the larger stage of the cosmos. It reminded us that there is still mystery, still beauty, still awe waiting above us. That reminder will outlast the comet itself. Atlas will fade as all comets do, but the questions it raised and the feelings it inspired will remain, carried forward in research, in stories, in memories, in the simple fact that we were here to see it. In the end, Atlas leaves us with the same message every interstellar traveller carries, that the universe is vast, strange, and alive with wonders, and that our best response is not fear, but curiosity. To witness Atlas was to witness more than a comet. It was to glimpse the continuity of worlds, the possibility of life elsewhere, the fragility of beauty, and the power of wonder. It came from beyond the stars, it shone brightly, and it left. And in that fleeting brilliance it reminded us that we too are travellers, brief but luminous, writing our own story in the light of the cosmos.